Hello children, how are you all? Hope so you are doing good. Yes, in the today's session we are going to discuss about a very important topic of class 10 ICSE, that is constructions. Keep in mind children, we are going to deal with all the different cases of constructions and different methodologies to construct the given circumcircle, incircle, to the triangle or to the hexagon, or construction of tangents as well. So keep watching the video till the end. Let us begin the first type of construction. Now we are going to deal with the case 1 of construction. Now let us see what is the case 1 says about. The case 1 says that to construct a tangent to a circle through a point on its circumference. A circle will be given to you. You have to construct a tangent to the given circle from any point on its circumference. So what I do here is, first of all, I'll draw a circle, any circle. For the example, I'll take a circle of radius 3 centimeter children. Okay, so now what I do here is I will take a circle of radius 3 centimeter. So this is the 3 centimeter. Now I will draw a circle. This is the circle of radius 3 centimeter. To this circle, anywhere I have to choose a point on its circumference. Okay, let us see, the point is over here. This is our point A. At this point A, I need to draw a tangent. Clear children? So what I do, I will draw a radius at this particular point. And you know that the angle between a tangent and the radius drawn at the point of contact is 90°. So what I do here is I will draw a 90° at that particular point. Clear children? At A. That is going to be the angle between the tangent and radii drawn at the point of contact. Clear children? So this is how I'm going to construct a 90°. All of you are familiar with the method of construction of 90°. I think so that need not be discussed. You all learned in your lower classes as well. Now this is the 90° and this is the required tangent. So you must make sure that this angle is 90°. O is the center of the circle. A is already taken. You can take any other letter. PQ I can say. So you can say PQ is the required tangent to the given circle. Now let us go ahead with the case 2. What actually case 2 says? Case 2 says that to construct tangents to a given circle from an exterior point, you are going to construct a pair of tangents to the given circle from an exterior point. You can see the example on your screen. So here the question says that construct a pair of tangent to a circle of radius 3 centimeter at a distance of 7 centimeter from it. So now what I do, I will take a circle whose radius is 3 centimeter. Okay, so I'll take a circle. I'll draw a circle whose radius is 3 centimeter children. So this is the circle. Now you have to construct a pair of tangent to this circle at a distance of 7 centimeter from its center. So this is the scale. Now I have to draw a line over here and a point. I call that point as P, which is 7 centimeter from the center of the circle. From this point, I need to construct a pair of tangent to the circle. So what I'm going to do, I draw the perpendicular bisector of this line. I call this line as OP. I draw a perpendicular bisector. You know what to do when you are supposed to draw the perpendicular bisector. You have to take more than half of the given line. Draw one arc with suitable length, one arc up and one arc down. Then keep the sharp edge of the compass at P and cut the arc whatever you have already drawn. Clear, children? Very simple construction. These kind of questions will be asked for 3 marks or 4 marks at least. Okay. So these all are very easily scoring marks, children. Clear? Right. So now I just draw a line over here which will be the perpendicular bisector of OP. So now where actually this perpendicular bisector is cutting OP, I'll call that point as Q. Now Q as the center, I will draw one circle passing through the center of the circle and the point P. This is the circle, that is the circle number 2. Now I got to know where the circle number 2, that's this, I just call it as a C2, and C1 is cutting the circle number 1, that is A, and B I call these points as. Now I will draw tangents P and A to be connected, P and B to be connected. So I can say that AP and BP are the required tangents, and you should not answer, you should not forget to answer the tail questions. You may ask to find out the length of the tangents. AP is equal to BP is equal to whatever length you get. Okay, you should mention the length of the tangent. Is that clear, children? Now let us go to the case number 3. Now see case number 3, children. Case number 3 says that to construct a tangent to a given circle from an exterior point when the angle between the radii at the point of contact is given. So the example is, consider a pair of tangent to a circle of radius 3 centimeter when the angle between the radii at the point of contact is 120 degree. So now the angle between the radii is given to you as 120 degree. So what you are supposed to do here, first of all, you have to draw a circle whose radius is 3 centimeter. So now I'll take my compass, I'll draw a circle whose radius is 3 centimeter. So you have to be very careful with the data, whatever is given in the question, children. Okay, right. So this is the circle whose radius is 3 centimeter. Now angle between the radii at the point of contact is 120 degree. Ideally, if you observe the rough figure, see what you are asked to construct. This is the circle. Here there will be two radii over here. The angle between them is given to you as 120 degree. So tangent should come like this, children. Correct. So now I have to draw the radii and construct 120 degree between those two radii. Okay. So now what I do, I'll take a radius over here. This is one radius. I'll call the center as O, and A is one radius. Now I'll construct 120 degree at O. All of you are aware how to construct 120 degree, children. Take a suitable length of the compass, then draw one arc like this. Don't change the length of the compass, keep the sharp edge over here. Cut the first arc whatever you have drawn, lift the compass and keep the sharp edge of the compass at this point, and cut the arc whatever you have drawn. Now this is your 120 degree ready. Clear, children? So now this is the another tangent, radii. Okay, so I call this as B. Angle between these two radii is 120 degree, and you know that the angle between the radius at the point of contact and the tangent is 90 degree. Now my job is to construct 90 degree at A and B. So I'll take again a suitable length of compass. It need not be the same length as you did in the previous case. All of you are aware how to construct 90 degree. So now I'll draw 90-degree over here now. Okay, so now construct 90-degree at this particular point, that is B. So you should use always sharp pencil, children. Okay, how sharp your pencil is, that much accurate answers you are going to get. You can verify whether whatever you have drawn the angle is 90-degree or not with the help of a protractor, nothing harm in it. Okay, so now I have constructed 120-degree. Now I need to bisect the angle between this 120-degree and 60-degree to get 90-degree. All of you are aware, you learned in your lower classes how to construct 90-degree, 60-degree, how to bisect the angle. Okay, so that's why I have not spoken about that. This is how I construct 90-degree at B. I'll draw one line like this. This is one tangent. So now what I do, I will construct 90-degree at A as well. Clear, children? So again and again I'm telling you, one construction guarantee, okay, from any of the previous year question paper, if you observe, okay, one question guarantee on the construction, so it should be perfect. These all are the questions which will easily give you the marks, children. No much trick or any of the skill is involved in this constructions. Clear, children? Only the thing is you need to be thorough with the methods. Correct, what to do to construct 90-degree, what to do to construct a tangent from the exterior point, what to do when I'm supposed to construct the tangents when the angle between the radii is given. Okay, so those kind of points need to be remembered. Clear? So now this is one more tangent. Okay, if you observe these two tangents, they are meeting at a point. Okay, this is the required point. Okay, I call it as P. So this is one tangent, this is another tangent. You concentrate on the methods, children. Okay, to be very careful, you need to concentrate on the method. Clear? Okay, now let us go to the case number 4. The case number 4 says that to construct circumcircle to a given triangle. So now angle will be given to you, triangle will be given to you, measurements of the triangle will be given to you. I'll draw a rough triangle here. Okay, that is A, B, C is a triangle where it is given to you that AB is equal to 6 centimeter. Okay, so I better take AB at the base. Okay, this is AB I will take, and C I will take. AB is equal to 6 centimeter is given to you. Then AC is equal to 5 centimeter. This is 5 centimeter. Then angle CAB is given to you as 60-degree. This is 60-degree. What I'm supposed to do, I'm supposed to construct a circumcircle. Circumcircle in the sense what, children? You need to be very careful that you are going to construct a circle which is passing through all the three vertices of the triangle. So now I'll construct triangle first. So 6 centimeter AB I will draw. This is AB. Then I will construct 60-degree at A. See the rough diagram. You have to draw the rough diagram which will help you and guide you, okay, how to go through the constructions. Okay, so this is 60-degree line. Now I will draw a line over here. This is 60-degree. Now AC is 5 centimeter. I'll take 5 centimeter in the compass. 5 centimeter in the compass. Okay, this is 5 centimeter. I'll cut this one. I need to locate C here. So this is how I have located C. Now I will join C and B. So this is the required triangle. Now if I want to construct the circumcircle, children, keep in mind I need to draw the perpendicular bisector of any two sides. Any two sides. Okay. So you know what to do to construct perpendicular bisector. So take more than half, one arc up, one arc down. So this is the perpendicular bisector of AB I am drawing now. Don't draw the bigger arcs. Okay, bigger arcs may confuse you. You may get confused which arc belongs to which side. Okay, this is the perpendicular bisector of AB I have constructed, children. Okay, so you can extend it in fact. Okay, right. So now I'll draw the perpendicular bisector of any of the other side. I will draw the perpendicular bisector of BC. Same method to be followed, children. Okay. Again, take more than half. Then after taking more than half, you have to draw one arc up, one arc down. Then change the compass to the other vertex. Change it to C now. Then cut the arc whatever you have drawn. You are cutting the arc whatever you have drawn earlier. Correct. So now you are joining this point of intersections. So where are they meeting, children? You can make a note of this. They are meeting at the point over here. Okay, this is the point. Now keep the sharp edge at this point. Adjust the length of the compass. Okay, so that it touches all the three vertices of the triangle. And draw, first check it whether it is touching or not. See, it is touching C, it is touching A as well. So now draw the circle. Clear? See, now it is coming perfectly, children. Okay, so this is the circumcircle of the given triangle. Here I may ask you to find out the radius of the circumcircle. That will be a tail question. You just measure this one. How much is the O, I can call the center of the circumcircle, OB. It will give you circumradius. Okay, circumradius, that will be your tail question. Don't forget to write the radius of the circumcircle. Clear, children? Now let's move to the next construction, next case. So case number 5, to construct an incircle to a given triangle. Clear? Just like the previous case, I'll construct the triangle. The rough diagram, I'll draw the rough diagram of the required triangle, children. So now the triangle is, look at this, whatever the data is given to you. AB is equal to 8 centimeter. AB is equal to 8 centimeter. Now AC is equal to 7 centimeter. This is 7 centimeter. Then BC is equal to 6.5 centimeter. This is 6.5 centimeter. Triangle construction you have learned in your lower classes. They may give you the varieties of triangle to construct. What is important here is how to construct the circumcircle, incircle. That is the important method. Clear, children? So now AB I'll construct 8 centimeter. This I call this as A here and B. Later AC I'm supposed to construct 7 centimeter. Rough diagram to be drawn that will guide you throughout the construction what to construct next. Okay, so 7 centimeter. This is 7 centimeter, which is the side AC is 7 centimeter. So I'll keep it at A and I will draw one arc. Okay, then BC is 6.5 centimeter. I'll keep it at O. Then I will draw I'll take 6.5 centimeter in my compass. Okay, you do along with me, children, so that whenever watching the video, if you do along with me, you will remember it. Okay, actually speaking, in ICSE, steps are not important, but don't forget to write the steps in 2 3 sentences. Okay, this is my third vertex C. Now I will connect A and C. I'll connect C and B. See, in the previous case, when I'm constructing the circumcircle, I drew the perpendicular bisector of any two sides. Now here I have to draw the angular bisector of any two angles, right? So to draw the angular bisector, what I'm supposed to do, I need to draw one arc like this. Pay attention, be very carefully, do along with me to avoid the confusion. Clear? Okay, so now here I will draw the angular bisector of angle A. Angular bisector in the sense what, children? It is nothing but the bisector of the angle, the line which divides the given angle into two equal parts. That is only called as angular bisector. This is the angular bisector of angle A. Now what I do, the angular bisector of angle B I will construct. Okay, so this is the angular bisector of angle B. Need to be very careful. I'm again I'm telling you to use the very sharp pencil to avoid the repetition of constructions in your exam. So now these both angular bisectors are meeting at a point. This point I'll call it as O. Now I'll keep the compass at O and adjust the length of the compass so that first check whether it is meeting all the three vertices, three sides of the triangle, since we are constructing the circumcircle. Clear? Okay, adjust it so that it is touching, okay, all the sides of the triangle. If it is not touching, adjust it, children, adjust it. Okay, ensure that it is touching. Okay, it should go like this. In fact, it has come out of the triangle. Okay, since we cannot manage in the software tools here exactly. Okay, so when you're doing in your book and all, care to be taken, this should not happen. Okay, even it should not come like okay, like this also, this gap should not be there, or the circle should not intersect the side also. Okay, so be very careful, it should exactly come like this. Look at this, how it has come over here. It should be like that, right? So what is the radius of the incircle here? It is nothing but the perpendicular distance from here to here. The perpendicular you have to draw. Okay, from here to here, if you draw the perpendicular distance here from this point P to O is nothing but the radii of the incircle. Clear, children? Okay, now let us move to the next construction, that is circumscribing and inscribing a circle to a regular hexagon. So now I am taking the regular hexagon and doing it. So here little bit a smart trick is there. Okay, what I do, the example given here, construct a circumcircle to a regular hexagon of side 3 centimeter. Basically, you know that what is the interior angle of a regular hexagon. Clear, children? So what is the interior angle of the regular hexagon? It is given by the formula 2n minus 4 into 90 divided by n. So hexagon in the sense 2 into 6 minus 4 into 90 divided by 6. You are going to get it as 120 degree. Actual construction says that you have to construct a side like line like this 3 centimeter, then construct 120 degree. Okay, then again you take 3 centimeter, cut it. At this point of intersection you have to construct 120 degree, then again 3 centimeter. At this point again construct 120 degree. again 3 centimeter 120 degree. Okay, again 3 centimeter 120 degree. It should meet at this point. But many of the children, what they do, they obviously they'll do a little bit of error over here. Your hexagon may not be a proper. This is the actual method. But what I'm suggesting you here is I'm going to tell you a method where we are going to get the exact regular hexagon. So for that, what you're supposed to do, you are supposed to do the circle construction of the circle first. Okay, so I'll take 3 centimeter in my compass and draw a circle first of all. Okay, so take 3 centimeter. This compass is not willing to come. Let me see why it is not coming. Yeah. Okay, so now 3 centimeter. These all are the software tools, children. You may be having a little bit of errors, but when you do with your compass, actual compass in your book with a sharp pencil, trust me, it is not going to, you are not going to get any of the errors. Okay, so now this is the circumcircle I have got. Choose any point over here on the circumcircle of the circle. Okay, I'll choose a point A. So here keep the sharp edge. Then your compass measures 3 centimeter. Obviously cross check it whether it is measuring 3 centimeter or not. So it is measuring, if it is measuring exactly 3 centimeter. Okay, so now what you're supposed to do, keep on cutting the circumcircle at different points. Okay, this is one point, then this is the second one, then this is the third one. Okay, hexagon in the sense, children, it is a six-sided polygon. Okay, there should be 6 sides for the polygon, whatever you are going to get. Clear? Okay, so now your hexagon is getting ready. So the last one exactly should go inside this point. Okay, so this is the point. Okay, it should actually pass through A. So now what are you going to do? You are going to join these lines. Look at this, right? So that are nothing but the sides of the hexagon. Make sure that you won't get the slant hexagon. Okay, this is the hexagon. After getting this one, every vertex, okay, I'm going to call this as B, C, D, E and F. Every vertex you have to show this construction, children. Okay, with the help of your compass, you have to show this construction that you are constructing 120 degree. Okay, right, evaluator should feel that you have constructed actual 120 degree. Okay, evaluator should not feel that you have constructed the triangle, I mean circle first, later you have constructed the hexagon. Okay, that hint should not be, okay, given to the evaluator. So that much accurate construction you have to do it. Okay, see how accurately it is coming over here. Okay, like that you have to show at each and every vertex, children. Okay, here also you have to show, right? Here also you have to show, here also you have to show. Method you need to understand, children. Here also you have to show it. Okay, right? So later, to draw the circumcircle, what we did in the case of triangle, we constructed the perpendicular bisector of the non-parallel sides. Okay, you have to construct a perpendicular bisector of non-parallel sides. In triangle there won't be parallel sides, but here they are parallel sides. So any non-parallel sides you choose, perpendicular bisector of any of the non-parallel sides you have to construct it. Okay, children. So now what I do, I'll choose AB first. I'll draw an arc here. Then I will draw an arc here. Okay. Then I lift the compass, keep over here, then cut this arc, cut this arc also. These two arcs are not cutting, so okay. Now this is the perpendicular bisector of one of the side. Okay, you can extend it, children, you can extend it. Okay, not necessary that it should be of the same length. Obviously you have got the center of the circle over here, they both should intersect over here. One more perpendicular bisector of any of the side I will take. I'll take this side. Okay, take more than half. Okay, then draw the perpendicular bisector of this side. Later lift the compass and keep it over here at E. Okay, so then you cut the arcs whatever you have drawn. 4 marks, children, 4 marks, no more tricks, nothing, only you have to be good, okay, in construction of these perpendicular bisectors. Okay, then angles and all. See, observe carefully, it is exactly, they are exactly meeting at the center of the circle, it is exactly meeting. Okay, so this is how you have to show. Clear, children? So basically you have to construct the perpendicular bisectors as well as you should show the construction of 120-degree at each vertex. See, all circles is exactly passing through the all the three vertices of the hexagon. This is how you are going to construct the circumcircle to the given hexagon. Now, case number 7. What is actually case number 7 says? Construction of incircle to the regular hexagon. Okay. Now, again, I'll take an example of 3 centimeter only. Okay. We are going to construct a regular hexagon of side 3 centimeter. For this also, keep in mind, children, what I do here is this circumcircle, whatever I'm going to draw. Okay, here look at this construction of circumcircle is in the same way. First of all, we are going to construct the circumcircle. Actually speaking, this method is what we are going to do now is for the incircle, right? To get the hexagon properly, I'm constructing the circle first, and just like the previous method, I am constructing the hexagon. I'm constructing the hexagon. Okay, so just like the previous method, I'm constructing the hexagon here. Later you have to erase this circle whatever you have drawn now. Okay, because you're asked to construct in circle should be inside. Okay, so that should not be outside. Okay, that's why the circumcircle should be erased later. We are drawing the circumcircle just to get a regular hexagon properly without any mistake. We are going to get the regular hexagon. See, I'm getting a regular hexagon here. Okay, just like the previous one, as I told you, show the construction of 120-degree, okay, in all the vertices. Okay, so this construction of 120-degree should be shown in all the vertices, children. Don't forget to do that. Once you have constructed this, okay, hexagon, this one should be erased, children. Okay, so whatever this line is there, this should be erased. Okay, because you are going to construct the incircle to the regular hexagon, keep in mind. So this circumcircle should be erased. Evaluator should not get a feel that you have constructed the circle first, then you have constructed a hexagon. No, this circle, you better what you do when you are drawing this circle, outside circle, you draw it very lightly so that you can erase it later. Okay, very quickly, very neatly you can erase it later. Okay, this is A, B, C, D, E and F. Okay, so this is hexagon. Now just in the case of triangle, what we did to construct the incircle, what we did, we bisected the angle. So similarly here we have to bisect the any non-opposite angles of the hexagon. Clear, children? So I'm going to bisect angle A. Okay, so angle A and any of the one more angle. Okay, so angle A I'm going to bisect first of all. After bisecting angle A, you can choose any of the non-opposite. Okay, the angle whatever you are chosen should not be the opposite angles. Clear, children? Okay, so over here, this is the angular bisector of A. Alright, you can extend it, no issues. Right, that is the angular bisector, and I will draw the angular bisector of any of the angle. Say for example, E I will choose. Right, so now I'll choose angle E and draw the angular bisector of angle E. Okay, children? So now I'm going to draw the angular bisector of angle E, suitable length of the compass. The only thing is, what I suggest you is, you should not get confused between which arc belongs to which angle. So soon after drawing the arc, make sure that you are bisecting it. Okay, so this is the bisector. Okay, see this, children. Okay, they both are meeting at this point. What is that point? This point. Okay, here. Now what I have to do, keep the compass, edge of the compass at this point, now adjust the length of the compass so that it is going to touch the sides of the hexagon. Exactly, it should touch. Okay, it is touching now. Now draw the circle. So this is your required incircle. The blue one is your required incircle which you are drawn inside the hexagon. This is the method. But I told you again and again, I'm telling you that the circle whatever you are drawn outside should be erased later. Evaluator should not get a hint that you have drawn this circle earlier. Clear, children? And don't forget to draw this 120-degree angle everywhere. It should be drawn everywhere. Clear? Right, so that, okay, it should be appearing such a way that you have constructed 120-degree then the hexagon. Clear? Yes, I hope so that today's video is very helpful to you. Please don't forget to subscribe the channel, like the video and share the video with your friends. So take care, keep working. Bye bye.